The tapestry of space unfurls before us, a boundless canvas stitched with the shimmering jewels of distant stars. Night after night, we raise our gaze towards this celestial spectacle, captivated by a sense of wonder and the illusion of a universe laid bare. Yet, what our eyes perceive, this sprinkling of starlight strewn across the seemingly desolate expanse, is but a facade. It conceals a realm far more intricate, vibrant, and unsettling than we could ever have imagined. For centuries, astronomers and philosophers alike have pondered the mysteries of the cosmos, seeking to chart its vast distances and unravel its inner workings. They embarked on their celestial journeys armed with telescopes that grew bolder, mathematics refined like a cosmic compass, and a sense of childlike awe in the face of the unknown. Yet, with each step they took towards deciphering the universe, a profound and unsettling truth emerged. The universe in its entirety is a grand illusion. Unseen forces operating in utter defiance of our intuition hold dominion over the fate of stars, galaxies, and the very fabric of reality itself. We call these enigmatic forces dark matter and dark energy. Invisible puppeteers, they pull the strings of the universe from the cosmic shadows. Though we cannot directly see them or feel their touch, their influence is undeniable, their fingerprints etched across the starlit sky and whispering to us from the very dawn of creation. Dark matter, the enigmatic sculptor of galaxies, is a silent leviathan. Its gravitational embrace cradles and contorts the visible world, its presence a whisper echoing through the swirling motions of distant stars. It acts as an invisible cosmic tapestry upon which the threads of starlight are woven, and there's dark energy, a force as bewildering as it is profound, a cosmic antagonist to gravity itself, stretching space with unrelenting and ever-increasing force. Like some unseen puppeteer, it works to manipulate the very stage upon which the cosmic ballet unfolds. Their true nature remains shrouded in mystery, a cosmic riddle that challenges the very foundations of physics and our understanding of the universe. But to pursue the secrets of dark matter and dark energy is to embark on a journey beyond the boundaries of human knowledge. It is to venture beyond the familiar realm of stars and planets, to seek fundamental truths hidden beneath the deceptive veil of our starry nights, and to unravel the threads of creation itself. Are you ready to leave the realm of the known and plunge headfirst into the cosmic unknown? To embrace the enigmas that dance on the fringes of our understanding and marvel at forces that defy all expectation? To grapple with concepts that strain the boundaries of our imaginations and venture into the heart of what makes our universe so unique, so mesmerizing, and so utterly mysterious? The gravity unseen, dark matter's dominion, the celestial waltz of stars and galaxies we witness masks a profound cosmic secret. It's a performance choreographed not just by the laws of gravity as we understand them, but by an enigmatic choreographer hidden backstage. This is the domain of dark matter, an elusive cosmic sculptor whose influence echoes across the vast expanse of the universe. Imagine dark matter as an ethereal force, a ghostly puppeteer manipulating the cosmos with quiet power. Unlike the stars, whose brilliance illuminates the night sky, dark matter betrays its presence only through its gravitational might. Its true nature eludes detection by our most sophisticated instruments, rendering it utterly invisible to our telescopes and sensors. Yet, while we may not be able to see this phantom choreographer, its handiwork is impossible to ignore. The story of dark matter's silent rule began long ago, in the fiery furnace of the early universe. In those chaotic moments that followed the Big Bang, both ordinary matter and its enigmatic shadow sibling emerged, born from a seething ocean of energy in a maelstrom of creation. Yet, with the passage of time, their paths diverged. As ordinary matter churned, clumped, and blazed with the light of newly formed stars, dark matter spread its tendrils outwards, weaving an intricate cosmic web across the emptiness of space. This cosmic web isn't merely a poetic image, it's a vast structure underpinning the entire universe. Picture dark matter as an immense sponge, its pores and filaments stretching across unimaginable distances. Galaxies, the glittering beacons of the night sky, cling to this ethereal network like morning dew caught in a spider's web. It was within the cradles of this sponge-like cosmic web that dark matter first asserted its silent rule. Its gravitational threads drew in swirling clouds of gas, providing the cosmic cocoons within which galaxies could grow. Without dark matter's scaffolding, the luminous wonders of the universe would simply not exist. But dark matter's reign extends far beyond the birthing chambers of galaxies. Like a cosmic puppeteer, it binds entire clusters of galaxies together, massive assemblages held fast against the relentless pull of the universe's expansion. And on a more intimate scale, it holds sway over the dance of stars, their dazzling orbits dictated not just by the gravity of their visible neighbours, but by the unseen embrace of this omnipresent cosmic force. Observational evidence: galaxy rotation curves. The silent choreography of dark matter is etched across the cosmos, but how do we know it's truly there? It was in the swirling motions of galaxies that astronomers stumbled upon the first compelling evidence for dark matter's existence. Imagine peering out into the night sky and observing a distant spiral galaxy, its majestic arms ablaze with the light of countless stars. You might expect the stars at the galaxy's edge, those furthest from the gravitational heart, to orbit sedately, their velocities held in check by the combined gravity of the visible matter within. But galaxies hold a profound secret: they spin far too fast. The outermost stars whirl through space at extraordinary velocities, as if bound by a gravitational force far greater than can be explained by the stars and gas we can see. This is not a minor discrepancy, but a dramatic departure from the laws of gravity, as established by Newton and Einstein. It's as if an unseen hand is stirring the cosmic pot, accelerating the swirling stars to impossible speeds. Astronomers meticulously chart how the speed of stars changes with their distance from the galactic center, creating what we call a rotation curve. If a galaxy's gravity was dictated solely by its visible matter, we would expect this curve to decline as we move further from the center, much like how planets in our solar system orbit more slowly the further they are from the Sun. However, this is not what's observed. Instead, galaxy rotation curves tend to flatten out, hinting at a vast and invisible halo of matter enshrouding the galaxy, adding its unseen mass to the cosmic equation. Observational evidence: gravitational lensing. The fabric of space-time itself is not as inflexible as we might imagine. Einstein's revolutionary theory of general relativity taught us that the immense gravity of massive objects can warp and bend the very geometry of the universe. Imagine space-time as a vast sheet of fabric stretched across the cosmos. A massive object like a star or a galaxy cluster placed upon this sheet would cause it to dimple and curve downwards, much like a bowling ball placed on a trampoline. Light, as it travels through the universe, follows the contours of this warped space-time. When light from distant galaxies passes near a region of immense gravity, such as a galaxy cluster, its path is deflected like a marble rolling near the dimple on our cosmic trampoline. This bending of light, a phenomenon we call gravitational lensing, gives dark matter another way to reveal its unseen hand. Much like a magnifying glass distorts and bends the light from objects behind it, a massive cluster of galaxies can act as a cosmic lens. The immense gravitational pull of both its visible matter and the vast quantity of unseen dark matter within it warps the surrounding space-time. When light from a more distant galaxy passes through this warped region, it can become spectacularly distorted and magnified. From our vantage point on Earth, we may see the distant lensed galaxy stretched and warped into dazzling arcs, its image duplicated or even multipled. These ethereal distortions offer a mesmerizing glimpse into the hidden gravitational forces at play. But gravitational lensing does more than just create beautiful cosmic illusions. By carefully studying the way distant galaxies are distorted and magnified, astronomers can perform a sort of cosmic reverse engineering. They can map out the distribution of matter, both visible and invisible, within the lensing cluster. What these meticulous calculations consistently reveal is that there simply must be far more mass present than can be accounted for by the stars and hot gas that we can directly observe. Once again, the evidence points to the silent presence of a vast ocean of unseen dark matter. The Bullet Cluster, a cosmic smoking gun. If gravitational lensing offers compelling evidence for dark matter, the Bullet Cluster clenches the case shut. This cosmic behemoth offers a dramatic testament to dark matter's existence. The Bullet Cluster is the consequence of two smaller galaxy clusters colliding and merging at unimaginable speeds. a cataclysmic event that forever changed the cosmic landscape within this region of space. In the aftermath of this immense collision, we can use various telescopes to map out where the different kinds of matter ended up. X-ray telescopes reveal the location of superheated gas stripped from the galaxies as they collided, creating a vast, glowing cloud in the shape of a bullet. By studying gravitational lensing, we can map out the overall distribution of mass within the cluster. Intriguingly, these two maps do not align. The majority of the mass, as revealed through lensing, is found in two distinct clusters offset from the cloud of hot X-ray emitting gas. This is the smoking gun. What the bullet cluster demonstrates so clearly is the separation of visible matter and unseen dark matter. Ordinary matter, the gas and particles within galaxies, interacts during these collisions, slowing down and heating up as it slams together. But dark matter, aloof and unresponsive to forces other than gravity, appears to have passed through the collision untouched, leaving a ghostly imprint of its passage in the distorted light of distant galaxies. The celestial tapestry, a swirling vortex of light and color, a spiral tapestry woven with dazzling star clusters, or a softly glowing elliptical giant nestled against the inky backdrop of space. Galaxies are the jewels of the night sky, each with its own unique story to tell. But their luminous forms are only a tantalizing glimpse into the true beauty and complexity woven into their invisible foundations. It's in the realm of unseen forces, orchestrated by the cosmic architect known as dark matter, where a galaxy's true genesis unfolds. Birth in the cosmic web. Recall the cosmic web, that ethereal network permeating the vast expanse. Think of it as the universe's skeletal system. Its dark matter filaments the unseen bones upon which all celestial bodies rest. It was within the depths of these immense tendrils that galaxies took their first breaths. As the early universe expanded and cooled, dark matter's gravitational threads gathered and condensed, forming vast halos, cosmic cradles suspended in the darkness. These halos weren't just empty space, but regions where darkness itself grew denser and more assertive. Ordinary matter, the gas and particles that would eventually ignite into stars, was drawn inexorably towards these gravitational wells, swirling and collapsing within the contours molded by unseen mass. Imagine these nascent galaxies as shimmering dewdrops clinging to an intricate spider web, luminous pearls strung upon the invisible strands of dark matter, the fire of creation. As clouds of gas plummeted deeper into the dark matter halos, they fragmented and ignited like cosmic fireworks. Countless stars burst to life, their brilliance piercing the cosmic darkness. But these were not just random explosions. The unseen puppeteer's gravitational influence subtly guided the process. These primordial stars and their swirling gas assembled themselves over cosmic timescales, their collective gravity and the enduring influence of the dark matter halo shaping the grand and diverse forms of galaxies we see across the cosmos. Dark matter's influence did not end with this initial burst of star formation. Its vast invisible halo continues to ensnare and shape each galaxy, acting as an unseen cocoon, preventing stars from spiraling into disarray. Without dark matter's steady hand, galaxies would fly apart, their delicate forms dissolving under their own centrifugal forces. The dance of light and shadow. The interplay between dark matter and visible matter is a celestial waltz as old as the universe itself. It's a testament to the silent sculptor's power that galaxies have maintained their distinct forms for billions of years, enduring cosmic storms and collisions while continuing to create new generations of stars, all while held together by a web of unseen power. A galactic zoo. The universe boasts a menagerie of galactic forms. Dark matter, while a unifying force, plays a nuanced role in shaping their diversity. Spirals. Think of a spiral galaxy as a cosmic pinwheel. They boast dazzling central bulges and graceful arms swirling outwards. Their rotation is integral to their structure, and dark matter acts as a counterbalance to ensure they spin at just the right speed to maintain their elegant shapes. Ellipticals. These ancient giants are more akin to fuzzy cosmic clouds than the structured spirals. Many are thought to be the result of galactic mergers, where dark matter acts as the gravitational glue holding the chaotic collision together. Irregulars, a catch-all term for galaxies that defy easy categorization. These often small and scattered galaxies are a testament to the fact that dark matter's influence can be as chaotic as it is unifying. The drama of galactic mergers. While many galaxies still bear the imprint of their undisturbed birth in the cosmic web, others have endured far more turbulent histories. The universe is a dynamic and ever-changing stage, and galaxies all too often find themselves locked in a gravitational waltz. When galaxies collide, their structures are ripped and warped by immense tidal forces. Stars are flung into wild trajectories, gas clouds collide and ignite in new starbursts, and entire galactic shapes can be permanently altered. Yet even amidst this cosmic chaos, dark matter plays a pivotal role. While visible matter within galaxies interacts violently during a merger, their dark matter halos often pass through each other like ghosts in the night. This phantom passage leaves a trail of gravitational distortions, offering further evidence of dark matter's unseen hand upon the cosmos. And ultimately, as the chaos of a merger subsides, both sets of dark matter coalesce to form a new, unified halo, shaping the strange and beautiful forms of the newly merged galaxy. The drama of galactic mergers. While many galaxies still bear the imprint of their undisturbed birth in the cosmic web, others have endured far more turbulent histories. The universe is a dynamic and ever-changing stage, and galaxies all too often find themselves locked in a cosmic dance with profound consequences. Imagine two majestic spiral galaxies caught in a gravitational embrace. As they draw nearer, their graceful arms twist and warp, tidal forces as relentless as ocean waves tugging them out of shape. Long streamers of stars are ripped from their parent galaxies, painting dazzling arcs across the cosmic canvas. Closer still, their gaseous hearts tangle and collide, igniting bursts of frenzied star formation as shockwaves ripple through clouds of stellar fuel. The cores of the galaxies, dense with stars and superheated gas, crash together in a blinding flash. For a cosmic moment, the merging galaxies blaze brighter than anything else in the surrounding night, a testament to the raw power of these celestial collisions. Yet, even amidst this chaos, dark matter weaves its influence. While the visible matter of the galaxies interacts violently, throwing stars off their orbits and igniting cosmic infernos, their dark matter halos often pass through each other like ethereal phantoms. This ghostly passage leaves a trail of gravitational distortions, whispers of unseen mass that further solidify the evidence for dark matter's existence. As the chaotic dance unfolds over millions and sometimes billions of years, a semblance of order is gradually restored. From the maelstrom of the merger, a new galaxy emerges, forever altered by its cosmic ordeal. It might be a giant, fuzzy elliptical, a testament to the destructive power of the merger, or it could settle into a strange and distorted shape, forever bearing the scars of its collisional past. But whether the final form is serene or chaotic, there is one constant. The combined dark matter halos of both galaxies coalesce to form a new, unified halo that shapes and stabilizes the newly formed galaxy. Once again, dark matter emerges as the silent architect amidst the dramatic transformation of cosmic structures. A cosmic toolkit. Astronomers aren't merely passive observers to these cosmic events. They wield a powerful set of observational tools to dissect and understand galactic mergers. Telescopes. Capturing high-resolution images across various wavelengths allows astronomers to witness the visual spectacle of mergers. Different wavelengths highlight various components. Hot gas glows intensely in X-rays, star clusters shine in visible light, and infrared reveals dusty regions of star formation obscured from normal view. Simulations. Powerful supercomputers allow astrophysicists to recreate galactic mergers. By inputting models of galaxy structure, gas content, and, most importantly, including dark matter, they can watch realistic simulations of these events unfold, testing their theories against the observational evidence. The Grand Tapestry, unveiling the cosmic web. As we've seen, the influence of dark matter isn't limited to the confines of individual galaxies. Its cosmic dominion extends far across the vast reaches of space. Shift your gaze from the dazzling pinpricks of individual galaxies to encompass a staggering cosmic scale. Here, the true legacy of dark matter's silent rule reveals itself. Recall the cosmic web, that ethereal network permeating the entire cosmos. It's here, within the unseen structure of the web, that we witness dark matter's artistry on the grandest of stages. Imagine the cosmic web not as a tangible structure, but as a map of gravitational influence etched across the fabric of reality itself. Vast filaments of dark matter stretch across the universe, unseen tendrils thicker than entire galaxy clusters. Picture them not as rigid structures, but as flowing rivers carving their paths through the cosmos, pulling galaxies along in their gravitational current. Along these immense dark matter filaments, galaxies cluster like jewels strung upon a cosmic necklace. The largest galaxy clusters, those containing thousands of galaxies, reside at the intersections of these filaments, marking crossroads within the grand tapestry of the universe. In between the filaments lie vast cosmic voids, eerily empty regions akin to barren deserts amidst the web's denser structures. The cosmic web was born in the fiery aftermath of the Big Bang. Initially, both dark matter and ordinary matter were distributed relatively uniformly, like microscopic grains of sand scattered across an invisible beach. But over the course of billions of years, gravity played its role. Regions with slightly higher densities of dark matter exerted a subtle gravitational pull, slowly but surely attracting more matter. As these regions grew denser, their gravitational influence amplified, steadily drawing in matter from ever greater distances while gradually starving the surrounding regions. Think of this cosmic drama as a dance of accumulation and depletion played out in slow motion across the universe. Imagine a vast, sandy desert under the scorching sun. Over time, the relentless wind will subtly shift the sands, gathering them into dunes in some places and leaving barren hollows in others. Now, expand this concept to a cosmic scale, with dark matter playing the role of the wind and the sands, representing the primordial matter from which everything in the universe is made. The universe as we see it today, with its tapestry of galaxies amidst immense stretches of emptiness, is a testament to dark matter's gravitational choreography set in motion at the dawn of time. And just as the patterns in the desert sand change over the seasons and years, the cosmic web continues to evolve. Galaxies flow along the web's filaments, collide, merge, and form anew. Mapping the web. Directly seeing the cosmic web is impossible, as it's woven primarily from invisible dark matter. However, astronomers have become masters of cosmic cartography. Galaxy surveys, meticulously mapping the positions of millions of galaxies across the sky, provides a tracer of the web. Clusters and filaments emerge as regions of overdensity. Lyman alpha forest, quasars, the intensely bright cores of distant galaxies, act as cosmic lighthouses. Their light, on its journey to Earth, passes through the web. Hydrogen gas within the filaments absorbs certain wavelengths, creating a forest of absorption lines in the quasar's spectrum that reveals the web's structure. Cosmic time. Understanding the intricate structure of the cosmic web is akin to looking at a single frame from a movie that has been playing since the universe began. Imagine a time-lapse video of the desert dune from our analogy. It would show an ever-shifting landscape sculpted by the relentless wind. The cosmic web is equally dynamic, morphing and evolving as galaxies themselves move, cluster and form under the relentless and unseen forces of gravity. The enigmatic counterpoint, unveiling dark energy. Imagine the cosmic web as a vast, intricate tapestry woven from the invisible threads of dark matter. Galaxies cluster at its intersections, and the grand dance of structure formation unfolds across eons. But this intricate tapestry is not static. The universe is a dynamic and ever-changing place, and here's where the enigmatic counterforce known as dark energy enters the scene. Dark energy is a mysterious form of energy that permeates all of space. Unlike dark matter, which exerts a gravitational pull, dark energy has what appears to be a repulsive force. It acts as a sort of cosmic anti-gravity, pushing the fabric of space-time itself to expand at an ever-accelerating rate. Think back to our analogy of the cosmic web as a tapestry. Imagine tiny hands reaching in from the edges, not to rip the tapestry apart, but to gently stretch it ever wider. That's the subtle but persistent influence of dark energy. Over vast stretches of time, this expansion has a profound effect. Galaxies, once bound together by the gravitational attraction of dark matter, find themselves hurtling further and further apart across the ever-expanding canvas of space. The mystery deepens. The nature of dark energy is one of the greatest mysteries in modern cosmology. We don't know what it is made of, how it interacts with normal matter, or even if it's truly a single entity. One prevailing theory suggests it's a property of space-time itself, a form of inherent energy woven into the very fabric of the universe. Another theory proposes the existence of a mysterious substance, quintessence, that fills the universe and exerts this repulsive force. The quest for answers. Despite the deep mystery surrounding dark energy, cosmologists are not sitting idly by. Here are some of the tools they're using to unravel its secrets. Redshift surveys. By measuring the redshift of distant galaxies, the stretching of their light waves as they travel across the expanding universe, astronomers can map out the expansion history of the universe. This expansion history offers clues about the nature of dark energy. Supernova Cosmology Project. This project meticulously studied a specific type of supernova, known as Type 1a supernova, to measure the expansion rate of the universe at different points in time. The surprising discovery was that the expansion rate is accelerating, hinting at the presence of dark energy. The ultimate fate of the cosmos. The influence of dark energy has profound implications for the ultimate fate of the cosmos. Depending on its properties, dark energy could lead to several possible scenarios. The Big Rip. In this catastrophic scenario, dark energy's repulsive force grows ever stronger, ultimately ripping apart atoms and tearing the very fabric of space-time. The Heat Death. A more likely scenario suggests dark energy will continue to drive galaxies further apart, eventually leading to a universe where stars are extinguished and a cold, uniform emptiness persists. The Great Unknown. Perhaps the most humbling possibility is that we simply don't have the scientific framework yet to understand the nature of dark energy, and its ultimate influence on the cosmos remains a mystery waiting to be unraveled. A turning point. As we delve deeper into the enigma of dark energy, we stand at a pivotal point in our understanding of the universe. Unraveling its nature will not only answer fundamental questions about the cosmos's expansion, but could also shed light on the very origin and ultimate fate of everything that exists. Beyond the data, implications of an accelerating universe. The discovery of dark energy wasn't merely the addition of another line in a cosmic encyclopedia. It was akin to discovering an unseen hand guiding the very course of the universe. The implications of an accelerating universe ripple far beyond the realm of pure science, stirring profound philosophical questions about the nature of reality, existence, and our place within the grand cosmic scheme. Let's consider one of the most fundamental questions of all: the ultimate fate of the cosmos. For ages, the prevailing thought was that the universe's ultimate destiny rested on a delicate balance. Gravity, the great cosmic sculptor, would eventually slow the expansion of the universe until one of two scenarios played out: the universe collapsing in a fiery big crunch, or a slow fading out as stars winked out one by one, leading to a cold, static, and incredibly lonely universe. Dark energy throws a cosmic wrench into this narrative. An ever-accelerating expansion paints a far bleaker and lonelier picture. Galaxies, now relentlessly driven apart, will fade further and further into the cosmic distance, eventually receding completely beyond our cosmic horizon. We will be left inhabiting a universe resembling an isolated island, devoid of the light and companionship of far-flung galaxies. In the very distant future, even the stars within our own galaxy will burn out. New star formation will cease, leaving behind a graveyard of black holes, neutron stars, and cold remnants of stellar glory. The once brilliant tapestry of the cosmos will be reduced to a seemingly endless and eternally expanding emptiness. But perhaps there's a silver lining tucked within this bleak picture. The discovery of dark energy reminds us that the universe is under no obligation to conform to our human expectations of order or permanence. Our current understanding of physics, as elegant and far-reaching as it might be, may still be missing chapters, perhaps entire volumes, regarding the fundamental forces shaping the cosmos. dark energy could be a clue leading us towards a paradigm shift in our comprehension of the laws of physics. There might be forces at play that defy our current models of gravity, quantum mechanics, and the very nature of space-time itself. Our current theories may, from the perspective of future discoveries, be viewed as quaintly naive, as early Earth-centric models of the solar system seem to us today. The enigmatic nature of dark energy, therefore, isn't a cause for despair, but rather a testament to the wondrous possibilities that still await discovery. It reminds us of the vast territories of the unknown that stretch out before us, territories ripe for exploration by generations of curious minds determined to illuminate the cosmos's darkest corners. Unraveling the enigmas. Research into dark energy. The discovery of dark energy thrust cosmology into uncharted territory, a realm of awe-inspiring unknowns. Scientists around the globe are rising to the challenge, their quest for answers fueled by a mix of curiosity and a deep desire to understand the fundamental forces shaping our universe. Here's a glimpse into those frontiers of cosmic exploration. The cosmological constant, one candidate for dark energy. One of the simplest, yet most perplexing explanations for dark energy lies in the concept of the cosmological constant. Originally introduced by Albert Einstein himself in his equations of general relativity, the cosmological constant represented a sort of intrinsic energy woven into the very fabric of space-time. It would generate a repulsive force, counteracting gravity and keeping the universe from collapsing under its own weight. However, Einstein had no evidence for a non-zero cosmological constant and later referred to it as his biggest blunder. Ironically, Einstein's blunder now appears to be a prime candidate for explaining dark energy. Think of the cosmological constant as a constant background level of inherent energy permeating every cubic meter of space. As the universe expands, more space is created, and thus more of this background energy comes into existence. It sounds bizarre, but this could explain why the expansion of the universe is accelerating rather than slowing down. The true mystery, however, is why the cosmological constant has the value it does. Our best theoretical calculations predict it should be many orders of magnitude stronger than what is observed to explain dark energy. This glaring discrepancy is one of the most frustrating open questions in modern physics. Quintessence, a dynamic force. Another possibility is that dark energy isn't a constant at all, but rather a dynamic force represented by a field permeating space, much like an electromagnetic field. This mysterious force has been dubbed quintessence. Unlike the unchanging nature of the cosmological constant, quintessence could evolve over time, its strength changing and even its effect potentially reversing if conditions were right. This offers a wider range of possibilities for the ultimate fate of the universe, with scenarios where dark energy eventually fades away or even reverses its repulsive effect, leading to an eventual cosmic collapse. The tools of the astronomer. The quest to understand dark energy isn't limited to theoretical whiteboard equations and computer models. It requires observational evidence to tease out the possibilities. Scientists wield a powerful arsenal of tools. Telescopes. Ground-based behemoths and spacefaring observatories, like the Hubble Space Telescope and its successor, the James Webb Space Telescope, offer unprecedented views of distant galaxies and supernovae, revealing the expansion history of the universe. Dark energy surveys. Specialized surveys like the Dark Energy Survey and the upcoming missions, like the Euclid Space Telescope and the Nancy Grace Roman Space Telescope, map huge swathes of the sky, creating detailed 3D distributions of galaxies, searching for clues in how dark energy has influenced the formation of cosmic structures. The cosmic puzzle. The true nature of dark energy is the ultimate cosmic puzzle. Is it the cosmological constant, quintessence, a sign of modified gravity, or something so wildly different it defies our current scientific imagination? Resolving this enigma is likely to usher in a new era in our understanding of the cosmos, an era where the very nature of reality comes into sharper focus. The tapestry's weavers, dark energy missions. Cosmologists aren't content to theorize from afar. They're launching ambitious missions and surveys that will revolutionize our understanding of dark energy, shining a cosmic spotlight on its elusive nature. Here are a few of the major players. The Dark Energy Survey. This groundbreaking survey, completed in 2019, utilized a powerful camera mounted on a large telescope in Chile to map out hundreds of millions of galaxies across an immense swath of the southern sky. By analyzing the distribution and distortions of these galaxies, the DES aimed to probe not just the expansion history of the universe, but the subtle influence of dark energy on the growth of cosmic structures over time. The Euclid Space Telescope. Set to launch in 2023, Euclid will take dark energy surveys to the next level. Its powerful optical and infrared cameras will peer further than ever before, mapping billions of galaxies and their spatial distribution across vast stretches of the cosmos. Euclid's goal is to pin down the behavior of dark energy throughout the universe's history, looking for any evidence of changes in its strength or behavior that could help unravel its origin. Nancy Grace Roman. Space Telescope, formerly known as WFIRST. This space telescope, slated for launch in the mid-2020s, packs the potential to transform dark energy research. It boasts a wide field of view and incredible sensitivity, allowing it to observe thousands of supernovae with high precision. This treasure trove of data will refine our measurement of the universe's expansion rate more accurately than ever before, allowing scientists to trace how dark energy's influence has changed with time, beyond mapping and measurement. These missions don't just catalogue distant galaxies and measure the expansion of the universe. They hold the key to testing fundamental concepts of physics. For instance, precise measurements of cosmic structure formation are sensitive to changes in how gravity operates on the largest scales. If the data gathered by missions like Euclid and Roman reveal discrepancies from Einstein's general relativity, it could indicate dark energy is a consequence of some modification to our understanding of gravity itself, a revolution in physics as significant as relativity itself. Moreover, by observing objects spanning immense stretches of cosmic time, these missions offer a window into how dark energy might evolve. If it's a cosmological constant, then its density should remain unchanging. However, even subtle changes over time would point towards a more dynamic origin and offer tantalizing clues as to the fundamental forces underlying this cosmic enigma, the cosmic frontier. The quest to understand dark energy isn't just about distant galaxies and exotic physics, it's about pushing the boundaries of human knowledge to its very limits. It's a tale of scientific ingenuity, of telescopes becoming our cosmic eyes that pierce the veil of what is known to reveal the invisible tapestry woven from dark forces. This quest is likely to rewrite textbooks and reshape our understanding of the very fabric of reality. The ultimate nature of dark energy could point to new forces beyond our current comprehension, a cosmic reminder that the universe is far grander, wilder, and more complex than we can currently conceive. The endless cosmos, a final reflection. The relentless expansion of the universe, fueled by the enigmatic power of dark energy, might seem to paint a bleak picture, a cosmos destined for isolation, fading lights, and unending darkness. It's a vision that challenges our sense of place and purpose within the grand sweep of cosmic time. Yet, even amidst this potential existential solitude, a spark of something undeniably human remains, the relentless fire of curiosity. We are a species of explorers, of questioners, of relentless seekers driven to illuminate the darkness. From charting the uncharted to unraveling the intricate workings of the atom, the pursuit of knowledge transcends boundaries, cultures, and eras. It is woven into the very essence of what makes us human. The discovery of dark energy, far from a cause for despair, is a clarion call, a reminder that the cosmos still teems with unanswered questions, with mysteries waiting to be unraveled. It's this insatiable drive that propels our greatest endeavors. We build telescopes that see further than ever before, peering deeper into the fabric of the universe. We craft theories as intricate and beautiful as the cosmos they seek to explain. And we launch ourselves into the vast unknown, driven by a deep yearning to understand our place within this grand and mysterious tapestry we call home. The ultimate nature of dark energy may forever elude our grasp. The universe might indeed be destined for a bleak and lonely end, but even amidst such unfathomable possibilities, the human spirit of exploration endures. We will continue our quest, venturing forth on a journey not only of scientific discovery, but of self-discovery. dark energy reminds us of the profound and humbling truth that the universe is vast, complex, and ever surprising. It challenges us to embrace the unknown, to celebrate the endless mysteries that lie ahead, and to let curiosity continue to guide us as we boldly chart our course through the boundless and ever-evolving cosmic ocean. The end.